Hello, I'm Ben, and you're watching The PhD Parent. In this video, I'm going to talk about how researchers typically test a causal hypothesis. And this is not going to be an extensive overview of how researchers go about this. I'm only just going to try and make a couple of basic points. But before I get started, in case you're not familiar with the term hypothesis, a hypothesis is an explanation of a phenomenon. For example, you could have the phenomenon that some kids are more anxious than others. And you could have the hypothesis or explanation that this variation in anxiety is caused by overprotective parenting practices. But for the moment, suppose that you have the hypothesis simply that A causes B. How do you work out whether this hypothesis is correct? The hypothesis generates two predictions that I want to focus on. First prediction is that if A causes B, then there'll be an association between A and B. So as a researcher, to test this prediction, what you would do is get a measure of A and a measure of B. You'd then run an analysis to see whether or not there is an association or correlation between your measure of A and B. So now suppose there is an association. Can you claim that you've shown that A causes B? No. And there are two reasons for this that I'll focus on. So one reason you can't claim that A causes B from this association design is because this same pattern of results would emerge if B causes A. For example, suppose that you have a hypothesis that sleep problems in kids, A, cause anxiety in kids, B. You find that worse sleep problems are associated with higher levels of anxiety. And this association could emerge because sleep problems cause anxiety or because anxiety causes sleep problems. You just can't tell. Now, another reason you can't claim that A causes B from this design is because there may be a third variable C that gives rise to the association between A and B. And this is the so-called third variable problem. So building on the previous example, suppose that overprotective parenting causes sleep problems in kids and causes higher levels of anxiety in kids. If this is the case, then the reason you get an association between sleep problems and anxiety is because of their shared relationship with overprotective parenting. And again, you can't rule this out from this design. Now you could run a variant of this association design in which you look at the prospective association between A and B. I don't want to focus on this too much, but in short, what you do is get a measure of A at time 1 and a measure of B at time 2, for example, a few weeks down the track or whatever. The reason for doing this is because if you get an association between A and B, you wouldn't be thinking that B causes A. And this is because B happened after A. That is, your measure of B was at time 2 and your measure of A was at time 1. And you're assuming that stuff that happens in the future can't cause stuff that's happened in the past. But you still have the third variable problem. So anyway, back to the hypothesis that A causes B. As mentioned, this hypothesis generates two predictions. First prediction is that if A causes B, then there'll be an association between A and B, as we've just been through. The second prediction is that if you manipulate A, then that will have a subsequent impact on B. And this is considered a powerful way of testing a causal hypothesis. So as a researcher, to test this prediction, the first thing you've got to do is manipulate A. So returning to the previous example where the hypothesis was that sleep problems in kids, A, causes anxiety in kids, B, there would be different ways of doing this. Well, one approach would be to get a bunch of kids who have sleep problems and give a random half of them an intervention intended to improve sleep, and the other half no treatment. Before and after you've delivered this intervention, you get a measure of A, sleep, and a measure of B, anxiety. And when it comes to your analysis, the first thing you've got to do is check whether your manipulation was successful. That is, are the kids who received the intervention now sleeping better than those who didn't? Let's assume they are, and so now you're able to test the prediction by looking at the kids' anxiety levels. So as shown in the graph, the prediction is that before you've delivered the intervention, there will be no difference in the anxiety between kids who are about to receive the intervention and kids who are not about to receive the intervention. However, after the intervention, kids who received the intervention and who are now sleeping better would be showing lower levels of anxiety compared to kids who didn't receive the intervention. Suppose this is what comes out. Now can you claim that you've shown that A causes B? In this case, you're in a much stronger position because this pattern of results wouldn't emerge if B, anxiety, causes A, sleep problems. The only real sticking point is the third variable problem. Now, if it were the case that your manipulation altered A and only A, then you'd be less concerned about the third variable problem. But in most cases I can think of, certainly in psychology research, it can be tough to get a pure manipulation of just one thing. That is, you can't entirely exclude the possibility that in manipulating A, you may have inadvertently manipulated some other variable C, and it's the latter that drives your effect. So that's the nature of research. And what you might do next is think of plausible other things that may have changed as a result of your manipulation. and carry out further experiments to test whether it's these other things that were driving the original effect. So that's a quick overview of testing causality. If there's anything I've gotten wrong, if you have any questions, then feel free to get in touch. Otherwise, happy parenting.